नेटवर्क ही करना है और कुछ करूँ अब? नेटवर्क, न्यू टॉपिक कोई? चलो कोई बेसिक ओम्स लॉ पढ़ दे। ठीक है। the the basic topic is a Ohm's law, is a Ohm's law. This is the new topic. This is the new topic. Is a basic topic of any electric circuit. In the network theory, the basic is a Ohm's law. The basic is a Ohm's law. Listen very carefully. Now, initially we discussed the R. Initially we discussed the resistor R. The resistor R is a passive element. The resistor R is a passive. The resistor R is a passive element. The resistor R is a passive element. The resistor R is a passive element. Listen carefully. Now, in any conductor, in any conductor, in any conductor, the cross-sectional area, let the consider the cross-sectional area is A, and the length of the conductor is L. The cross-sectional area is A, and the length of the conductor is A. If current is flowing, if current is flowing is I, if current is flowing is I, if current is flowing is I, then the definition of the Ohm's law, the statement of the Ohm's law are very, very important. This asked in the interview. The statement: at any constant temperature, at any constant temperature, at any constant temperature, at any constant temperature, current density current density is directly proportional to electric field intensity. It directly proportional to electric field intensity. In at any constant temperature, current density is directly proportional to electric field intensity. Current density is directly proportional to electric field intensity. Current density is a J, directly proportional to E. What is J? J, current density, what is J? The current per cross-sectional area, the current per cross-sectional area, the current per cross-sectional area is called current density. The current per cross-sectional area is called current density, J. The J, by the definition J, this is equals to I upon A. I upon I upon A. I upon A. Now J is equals to sigma E, and the electric field intensity is equals to V by L, where V is any battery, which are connected with the inductor, which are connected with the conductor, and because of the battery V, the current flowing in the conductor is a I. Then E is equals to V by L, V by L. This is the electric field intensity, and the sigma is called the conductivity. Sigma is equals to 1 by rho. Sigma is called the conductivity, and rho is called what? Rho is called the resistivity. Rho is called the resistivity. Now put this value J equals to I by A, E is equals to V by L, and sigma is equals to 1 by rho in the equation number 1. In the equation number 1. Put this value in the equation number 1. J is equals to, this is the I by A. This is equals to sigma. Sigma is equals to 1 by rho, and E is equals to V by L. So this I by V, this is equals to A by rho L. So rho L by A, this is rho L by A. This is equals to V by I. V by I. The rho L by A quantity, the rho L by A, this is equals to R. This is equals to R. V by I. R is a resistance. R is a resistance. V by I is equals to R. So V by I is equals to R. V is equals to IR. This is the Ohm's law first form. This is the Ohm's law first. This is the Ohm's law first form. But in the interviews, one simple question is asked. In simple question asked, the first definition, the first statement of the Ohm's law is: at any constant temperature, current density is directly proportional to electric field intensity. And the last derivation, last is R is equals to V by I. V is equals to IR. R is any constant quantity. R is any constant. V is equals to IR. So here two things are there. V is proportional to I, and the I is proportional to V. I is proportional to V. So which two are, this both are Ohm's law? Yes, only one are Ohm's law. Then the interview, this question asks Ohm's law what? V proportional to I proportional to V. These both are the Ohm's law. These both are the Ohm's law. Listen the one example. Listen. This is This is 1 ohm resistor. This is 1 ohm resistor. This is 1 ohm resistor. This is 1 ohm resistor connected with this 1 ohm resistor connected with 1 volt battery. Connected with 1 volt battery. Now, if you see this 1 volt is called what? This 1 volt is called the EMF, which are independent of, resistance and the current, which are independent of resistance and the current magnitude. The EMF is independent of, the EMF is independent of, the EMF is independent of I, current magnitude, and magnitude of current and the voltage magnitude. EMF is independent of I and the V. Now, if you see in this case, I is because of what? I is because of EMF. I is because of EMF. The V 1 volt, this is called the cause. This is called the cause, and this I, and the because of this, one potential difference are generated in the 1 ohm resistor. So these two are both are correct, but again is asked which are the first, which are the second, which are the first, which are the second. The first is I proportional to V. The first is I proportional to V. The V is a EMF. Okay. The V is a EMF. The V is a EMF. Because of EMF, current is created. Because of EMF, current is generated. Because of the current is flowing in the circuit is because of EMF. So I is proportional to V is a first. I proportional to V is a first. And the second one, the current is flowing. So because of this current, potential difference across the 1 ohm resistor is V is a V. Let the consider is a V. And let consider this is the EMF. This V is a EMF and this V is a potential difference. This V is a potential difference and this V is a EMF. So this one is a first and this one is a second. This one is a second. This one is a first and this one is a second. The next is the next is the V is equals to IR. The V is equals to IR. V is equals to IR and the J is equals to sigma E. At any constant temperature, current density is directly proportional to electric field intensity. Okay. Next definition, the similar definition, and the at any constant temperature, potential difference is directly proportional to current. Now V is equals to IR. This is the first form of Ohm's law. This is the first form of Ohm's law. This is the first form of Ohm's law. Now this V is equals to IR. I is called the current. R is also equals to 1 by G. R is also equals to 1 by G. So V is equals to this I by G. So this is equals to V into G. I is equals to VG. This is the second form of Ohm's law. This is the second form of Ohm's law. We also know I is equals to dq by dt. We also know I is equals to dq by dt. So V, this is equals to R dq by dt. This is the third form of Ohm's law. This is the third form. This is the third form of Ohm's law. 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 So this is all about the Ohm's law. This is all about the Ohm's law. Now next we discuss the simple resistor. What is the resistor? Simple resistor. What is the resistor? Resistor, R is equals to rho L by A. R equals to rho L by A. You know the formula of resistor is R equals to rho L by A. On the basis of rho, rho is a resistivity. On the basis of rho, there are three types of resistor. There are three types of resistor. Low rho, low, and the medium rho, and the third one is called the high rho. High rho. R equals to rho L by A, resistor equals to rho, low rho, medium rho, and the high rho. If a high rho, low rho, then the conductivity is high, then the material is called as the conductor. The three classifications of the material, one is a conductor, second one, third one is a high rho. High rho is a insulator, and the medium rho is the semiconductor, is a semiconductor. If rho is equals to 0, if low rho is a conductor, if rho is equals to 0, then the conductor is called superconductor. Then the conductor is called superconductor. If rho is equals to 0, then the conductor is called superconductor. If rho is equals to 0, then the conductor is called superconductor. Mercury at 4.15 Kelvin, mercury at 4.15 Kelvin is a superconductor. This question is asked in the exam. Mercury at 4.15 Kelvin is a superconductor. Is a best example of superconductor. Mercury at 4.15 Kelvin is an example of superconductor. Mercury at 4.15 rho is equals to 0. That's why this is a superconductor. Next, next we consider one resistance. What is the resistance? What is the resistance? This is a R. Resistance is a property of resistor. Resistance is a property. Resistance is a property of resistor. Resistance is a property of a resistor. Resistance is a property of